Hi, welcome to the video solution for mathematics. This is Edexcel IAL Mathematics C12 January 2017. Let's start. Question number 6. The straight line L1 has the equation 2y is equal to 3x plus 5. The L1 cuts the x-axis at the point A as shown in the figure 2. This is the line L1 and this is the point A. State the gradient of L1. We need to find the gradient. That means if you compare this equation with y equal mx plus c, so you need to first rewrite this equation as y equal mx plus c. So you can rewrite L1 equation as y is equal to 3 by 2 x plus 5 by 2. That means the coefficient of x gives you gradient of the line L1. So you can say that gradient of L1 is m1, which is equal to 3 by 2. Part 2, write down the x-coordinate of the point A. The point A is on the x-axis. That means A is x-intercept. X-intercept. And remember, for x-intercept, y value is always 0. That means you can substitute y in the equation of L1 to figure out the value of x, the x coordinate of the point A. So you put y equal to 0. So if you put y equal to 0, that means 2 times of 0 is equal to 3x plus 5, and x is equal to 5 by 3. And if you send minus on the other side, it's a minus 5 by 3. This is x coordinate. That means coordinate of A would be equal to minus 5 by 3 comma 0. Another straight line L2 intersect L1 at point B with the coordinate x coordinate 1 and crosses the x-axis at the point C as shown in the figure. Given that L2 is perpendicular to L1, find an equation for L2 in the form of ax plus by plus c, where a, b, c are integers. We need to find equation of L2, and remember L2 is perpendicular to L1. In this case, if two lines are perpendicular, that means the second slope M2 is the reciprocal of the first slope with change of the sign. Whatever the sign of the first slope or gradient is, we just change the sign. That means for L2, gradient would be equal to minus 2 by 3. You can see that M1 is 3 by 2, so M2 would be equal to, we take the reciprocal and change the sign. So minus 2 by 3, this is gradient M2. And point B also lies on L1. So in order to find the coordinate of B, we can use equation of L1 because point B lies on both lines. So we know that x coordinate of B is 1, comma, we need to figure out the y coordinate. So we can substitute x equal to 1 in the equation of L1. If you do that, that means 2y is equal to 3 times of 1 plus 5. That means 8, and 2y is equal to 8, so y is equal to 4. That means coordinate of B is 1 comma 4, and the point B also lies on L2, so we can use point B to find the equation of L2. And for L2 equation is we use slope point form, y minus y1 is equal to m times of x minus x1. Remember, this m is the gradient of the line, and x1 and y1, these are the point on the line. In this case, this gradient is minus 2 by 3, and this x1 and y1 is 1 and 4. If you substitute the value, y minus 4 is equal to minus 2 by 3 x minus 1. You simplify this equation, so 3y minus 12 minus 2x plus 2, and then you rearrange in the form of ax plus by plus c. So finally you have equation 2x plus 3y minus 14 equal to 0. This is the equation of your line L2. C. Find the exact area of the triangle ABC. Triangle ABC. So if you see the diagram, we know that this is the triangle ABC, and for triangle ABC we have a concept of area of the triangle, which is area of the triangle area is half of base into height. In this case, base is A to C and height is from B to x-axis. So we have coordinate of B, and you know that the y coordinate of B is 4. That means the vertical height of the triangle is 4. So we have height, and in terms of base, yes, for the base, you know that O to A, we have found the coordinate of A as minus 5 by 3. That means from O to A, this distance is 5 by 3. I'm talking about distance, not the position. That's why the distance is 5 by 3. And what about, so if you can figure out coordinate of C, so we can have a distance from O to C. The x coordinate of C will give you distance O to C. And how do we do that? Again, point C lies on the line L2. We have found the equation of L2. So we substitute y equal to 0, because this is x-intercept for L2. So 2x plus 3 times of 0 minus 14 equal to 0. Clearly, if you find x is 7, that means coordinate of C is 0, 7, 0. So the base is 5 by 3 plus 7 and height is 4. So you can say that the area of the triangle, area is half of base, and base is 5 by 3 plus 7. This is base plus 7 into height. Height is 4. You can simplify this expression, so your area A will be equal to 52 by 3. This is your area. Okay, question number 7. Find integral of 2 plus 4x cube over x square dx given each term in its simplest form. Remember, if we have a variable in denominator, we cannot integrate x square and denominator. So before integration, we need to simplify this integrand, which is 2 plus 4x cube over x square. And how do we do that? We separate x square underneath every numerator. So we say that 2 over x square plus 4x cube over x square, and then this x square will cancel x square in numerator. So finally you have 2x to the power minus 2 plus 4x. So now you can easily integrate this. So how do we integrate? We have a power rule. If we have integration x to the power n dx, no matter if we have a coefficient, it doesn't matter, we can write coefficient as it is, but the integration of x to the power n is x n plus 1 divided by n plus 1 plus c. So we apply the rule of integration, the first basic rule. So 2 is a coefficient, it stays same, x to the power minus 2 plus 1 divided by minus 2 plus 1 plus 4 x. So 1 plus 1 divided by 1 plus 1. This is intermediate step. If you are okay, you can skip. So finally you have a 2x to the power minus 1 divided by minus 1 plus 4x square over 2, and then you can further simplify. You can say that minus 2 over x, I am sending x to the power minus 1 in denominator, so it becomes minus 1 becomes plus 1, x to the power plus 1, and this to cancel, 2 x square plus c. Don't forget to write plus c when you are integrating. So this is your final answer. Part 2. Given that k is a constant and 2 to 4 over root x plus k dx is equal to 30, find the exact value of k. Again, this is a definite integral, limits are given. So first step is similar, we need to integrate the bracket. So how do we integrate? First we need to send root x in the numerator, so we can write this as integral 2 to 4 x to the power minus half plus k dx, and then you can integrate. So you can integrate the first term, which is 4. I'm going to call this as I equal to this. So I equal to 4 x to the power minus half plus 1. Remember, xn plus 1, so power is minus half. So minus half plus 1 is half divided by half plus k is constant, so integral of constant is kx. So this is the integral, and because this is definite integral, we don't write c, instead we write limit 2 to 4. First we simplify this, so this 2 goes up and it becomes 8x to the power half plus kx, and the limit is 2 to 4 I. Moreover, applying limit, so I is equal to upper limit minus lower limit. So first we need to apply 4 in place of every x. So 8x, 8 into 4 into half plus k into 4, k4 or k into 4 minus, I'm going to write a bracket because I'm applying lower limit. So 8 root 2 plus 2k. And if you simplify this, you will have 4 to the power half, or root 4, which is 2 times 8, 16 plus 4k, which is this, and you open the bracket with the minus sign, so minus 8 root 2 and minus 2k equal to I. 4k and minus 2k will give you 2k, so 16 plus 2k minus 8 root 2 equal to I. Finally, I know that the integral is given as 30, so this is my value of I. So I can say that 16 plus 2k minus 8 root 2 equal to 30. Clearly, this is the equation only in terms of k. You can make k as a subject, so you will have k is equal to 7 plus 4 root 2. This is the value of k. Question number 8. F of x is equal to 2x cubed minus 5x squared minus 23x minus 10. Find the remainder when f of x is divided by x minus 3. Okay, so find the remainder when f of x is divided by x minus 3. Whenever you are given some polynomial and you need to find remainder, if some divisor is given, so that means you put x equal 3 in the polynomial. That so for part A, you say that f of 3 is equal to 2 times of 3 cube minus 5 times of x square minus 23 times of into 3 minus 10. And if you solve this, then f of 3 will give you, f of 3 is minus 70. So this is the remainder of your polynomial if the polynomial is divided by x minus 3. Part B, show that x plus 2 is a factor of f of x. So if some expression is factor of some polynomial, that means again if you put x equal to minus 2 in the given polynomial, and at the end if you get 0, that means the given expression is a factor of the given polynomial. So you can say that we did the same thing in part A. We were given x minus 3 and we substituted x equal to 3 and we got minus 70. That means f of 3 is not 0. So we can say that x minus 3 is not a factor of the polynomial. And we do the same thing for x plus 2 to check whether x plus 2 is a factor or not. If it is a factor, we should get f of minus 2 equal to 0. So let's try f of minus 2. So if you do that, so 2 times of minus 2 cube plus minus 5 times of minus 2 square minus 23 times of minus 2 minus 10. And if you solve this, if you simplify all these numbers, f of minus 2, you will get 0. That means x plus 2 is a factor of f of x. You can check in your calculator. It should get 0. C, hence fully factorize f of x. Again, this is a typical question of these kinds of question. They generally, if they give us a third degree polynomial or cubic polynomial, like this, we have a cubic polynomial, and if they give some expression as a factor, of the given polynomial, the next question is generally they ask us to factorize fully of the given polynomial, factorization. So the one method is we use long division to find the quadratic factor, and that's what I'm going to do here. You need to divide given polynomial 2x cubed minus 5x squared minus 23x minus 10 divided by x plus 2, because x plus 2 is the factor of the given polynomial we have proved in part B. So we expect that at the end of this division we must get 0 as a remainder, and we must have quadratic polynomial as a quotient. And how do we divide these expression? So you need to think some number or some expression to be written here, so that when you multiply this expression with the first term, you must get the same first term of the polynomial. In easy word, you can think that you in your mind you are dividing 2x cubed, the first term of the polynomial, divided by the first term of the divisor, x. And if you do that, you have 2x square, and this 2x square you write first term of the quotient. And the next step is you multiply this 2x square with every term in divisor. If you do that, so you have 2x square multiplied by x, you must get same term 2x cubed, and then 2x square multiplied with the 2, so it will give you plus 4x square, and then you change the sign. Always first term should get cancelled, and then rest of the term you write here. So 5x minus 5x squared minus 4x squared, it will give you minus 9x squared, and then rest of the term you write as it is. So minus 23x minus 10, and then again you do the same thing. The first term minus 9x, so minus 9x squared divided by the first term of the divisor, x. Cancel, your answer is minus 9x. That means you must write minus 9x as the second term of the quotient, minus 9x, and this minus 9x now is multiplied with every term of the divisor. So minus 9x squared, and then minus 18x, and then again you change the sign, this become plus, they will get cancelled, and minus 23x plus 18x will give you minus 5x, and this minus 10 underneath, minus 10. Again, the first term minus 5x is divided by the first term of the divisor, x. Answer is minus 5. This is third term of your quotient, so minus 5, and then minus 5 is multiplied by every term in divisor, so you must get minus 5x, this 5x multiplied by x minus 5x, and then this minus 5x multiplied by 2, so minus 5x and then minus 10, and you see that we have changing the sign, and you can cancel, you must get 0. So now we have first factor of the expression is x plus 2 and the second factor is 2x square minus 9x minus 5. This is the quotient of my process, my division process, and this is the second factor. And you can see that this is the quadratic expression and you can factorize this expression easily. You can use quadratic formula, you can use completing square method or simple factorization method to factorize this expression. And how do we factorize this? Because we don't have a coefficient of square as 1, so I will be looking at as a constant multiplied by the coefficient of square. So you will get 10. 5 times 2 is 10. So you need to think factor of 10 so that this factor, if you subtract those factor, you can get minus 9. So I have 10. So the only factor of 10 is 10 times 1, and clearly can we get minus 9? Just look at the sign. Can we get minus 9 after subtracting these factor? Of course, if we have minus 10 and plus 1, that means you can rewrite this expression as 2x square minus 10x plus 1x or x minus 5. Now I have 4 terms. I can take 2 commons from the first one. So 2x is common. Inside bracket I have x minus 5, and from here I will take 1 common. I have x minus 5. Finally I have factor x minus 5 and 2x plus 1. So these are rest of the 2 factor. So you can write your final answer as all factors are x plus 2, x minus 5, 2x plus 1. These are 3 factors of our polynomial. Part D, hence solve 2 to the power 3t minus 5 3 2t minus 23 3t. If you see, you are given 3 to the power 3t, 3 to the power 2t and 3 to the power t. So 3 has a power 3t, 2t and then t. We have these 3 powers of this base 3. In these types of situation or question, if we need to solve these types of situation, what do? We always assume the least t terms as new variable. So I'm going to assume I can take any variable, let x is equal to 3 to the power t. That means I can rewrite the whole equation as 2x cube minus 5 x square minus 23 x equal 10. How did I write x cube? You can see that 3 to the power 3t can be written as 3 to the power t whole power cube, because power to the power is always multiplied. and this 3 to the power t, I assume this is my x. This is x, this is q. Similarly, 3 to the power 2t can be written as 3 to the power t whole square, and this is x, so x square. So now if you see this, the equation has transformed as per given polynomial. So you can rewrite this as 2x cubed minus 5x square minus 23x minus 10 equal to 0. And we have already factorized in previous part C. And remember, just for your understanding, we had three factors of this equation, which was x plus 2, the first factor, and the second factor was x minus 5, and the third factor was 2x plus 1. So I can find three different values of x from these factors equal to 0. So I can say that I have x equal to minus 2 and x equal to 5, and then x is equal to minus 1 over 2. So now I have x, values of x, so I can figure out value of t. And how? First I choose x equal to 2. So if I choose x equal to 2, so I will have minus 2 is equal to 3 to the power t. And this is exponential equation. If we need to find t, we need to take log. So if we need to take log, taking log of any base, so log 10. So log of base 10 of minus 2 is equal to t log of base 10 of 3. I applied log rule because I brought t down. I did these two steps just for your understanding, because as soon as you write minus 2 equal to 3t, you can stop here, because you know that we cannot calculate log of a negative number. If you use your calculator and try to find log of minus 2, your calculator will give you systematic error or math error. That means we cannot find log of negative number. So for our situation, x cannot equal to minus 2, even x cannot equal to minus half. So the only option remain is x equal to 5. That's how you do that. So you use x equal to 5 and you say that 5 is equal to 3 to the power t, and again you take log on both sides. So if you apply log of base 10, so you say that log of 5 is equal to log of 3 to the power t, and then t comes down. So log of 5 divided by t times of log of 3, and t is equal to log of 5 divided by log of 3. Finally, t is 1 point. We need to find 3 decimal places, so 1.465. Question number 9. Figure 3 shows a sketch of the curve with y equal to f of x, where f of x is 8 by x plus half of x minus 5. X is between 0 and 12. The curve crosses the x-axis at 2, 0 and 8, 0 and has a minimum point at A. use calculus to find the coordinate of point A. Whenever they give you equation of the curve like this, and they said that there is a maximum or a minimum point on the curve, the idea is you need to differentiate the equation of the curve. That means you find first the step number one. The step number one is first you find dy by dx or f dash of x, because this is the derivative. And then step number two is, after finding the derivative, you equate this derivative f dash of x equal to 0, and then you figure out the values of x, and these are the x coordinate of minimum or maximum point. So exactly what we are going to do here, because we need to find the coordinate of the minimum point. This is our equation. So I'm differentiating f of x, meaning I'm finding f dash of x. So f dash of x would be equal to, if you differentiate 8 by x, so it will give you minus 8 x minus 2 plus half, because the derivative of minus 5 is 0. Finally, f dash of x is minus 8 by x square plus half, and for minimum, f dash of x should be 0. So minus 8 by x square is equal to minus 8 by x square plus half equal to 0. And you can solve this equation for x. You send minus half on the other side, so minus 8 by x square is equal to minus half, and then minus minus get cancelled. 2 times 8 is 16, so x square is equal to 16. When you take the root to find the x, so x will give you plus minus 4. But in a given condition, x cannot be negative, it's just between 0 and 12, so you ignore negative 4, so x is equal to just 4. So this is the x coordinate of 4. And what about the y coordinate? You substitute x equal to 4 in the original equation, so f of 4, it will be your y coordinate. So f of 4 is equal to 8 by 4 plus half of into 4 minus 5, and once you solve it, f of 4 would be equal to 4 2 2 2 2 times 2 4 4 minus 1 minus 1. That means a coordinate of a would be equal to 4 comma minus 1. Part B, state the roots of the equation 2 of fx. Okay, this 2 of fx, this is transformation situation, and you know that if some function is being multiplied some number, that means the function, the graph is stretched along the y-axis. So this is called vertical stretching. In vertical stretching, only y coordinates of every point are multiplied by the factor given in the condition, is in this case multiplied by 2. Only the y coordinate of every point. So you can see that I have point 20, which is the first root of the original equation. and 80 is the second root of the, so 2 and 8, in fact 2 and 8 are roots, or 20 and 80 are coordinates of the point on the x-axis. So what is the meaning of 2fx? Only y coordinates are multiplied by 2. So if you see that both y coordinates are 0, that means after stretching the y coordinate stays same, so there is no change in the root. So root of this equation for 2 of fx remains same. That means your roots are still 2 and 8. These are the root of 2 of fx. The coordinates of the turning point on the curve y equal to f of x plus 2. F of x plus 2, this is called vertical transformation. That means I generally say f of x plus 2 is a vertical shift. Vertical shift. You shift the whole graph 2 unit up or down depending on the sign given. Meaning if you have a f of x plus c, that means c unit up. Or if you have f of x minus c, so you will go the whole curve without changing any coordinate. The original shape will shift or transform c unit down. So they are saying f of x plus 2. So the curve, remember the coordinate of a we have found as 4 minus 1. And you need to figure out coordinate of that turning point of f of x plus 2. F of x plus 2 means the curve is going to shift, vertically shift 2 unit up. That means if you take the whole curve in upward direction, so the point A, this is 1 unit and another unit. So this is the new position of A. And this new position, the coordinate of this as per 2 unit shifting situation is A, the new coordinate of the point. So x coordinate remains same, which is 4, but the new coordinate will be minus 1, 0, and then 1. So the coordinate of the turning point is 4, 1. The roots of the equation f of 4x. Remember, in this original roots are 2 and 4. And the coordinate of these points are 2, 0, 8, 0. And if we have f of cx, this is called horizontal stretching. Horizontal stretching. In this case, only x coordinates, are multiplied by 1 upon c. Only x coordinates are multiplied by 1 upon c. Whatever the number is, you take the reciprocal and multiply with the x coordinate. That means the first roots are 2, 0. If you multiply it by, because this is 4x, so multiply by x coordinate multiply by 1 upon 4. It will give you half, 0. And then the second roots coordinates are 8, 0. Again it will be multiplied by 1 upon 4. It will give you 2, 0. So the new roots for the curve f of 4x are half, 2, or you can say half, 0, or 2, 0. These are the new position of the root. Question number 10. The first three terms in ascending power of x in the binomial expansion 1 plus ax to the power 20 are given by. So 1 plus 4x plus px square, where a and p are constant. Find the value of a, find the value of p. It is a binomial expansion. So you know that if you have expansion 1 plus x whole power n, it's a general expansion. And how do we expand these kinds of binomial? We start with the first term, which is 1. So 1 plus this n is multiplied with the x. So 1 plus nx plus n minus 1 and then x square over 2 factorial plus you follow the same pattern. At the second term you had n and then it becomes n minus 1 and x square. So the next term should be n minus 1, n minus 2 and then x cube. If you have a cube, you divide it by 3 factorial. Just for your understanding, I am writing one more so you can understand. The next term would be n minus 1, n minus 2, n minus 3, x to the power 4 divided by 4 factorial. That's how we expand a binomial if it is starting with 1 plus with some variable. So let's apply this on 1 plus ax. So 1 plus ax starting with 1 plus 20 times of ax, because this is the second term, ax plus 20, this is n minus 1, 90, and then x square. So a square x square upon 2 factorial. I don't need to write the third one because if you see we are given only 3 terms in expansion, so these 3 terms are sufficient. So first we need to simplify this. So you can say that 2 factorial is 2, so 2 and 20 cancel, you have 10, so you can rewrite 1 plus 20 ax plus 10 times 90 is 19 is 190 a square x square, and then clearly you can compare the second term. So 1 is 1, this is same, but here you have a 4x, here you have a 20ax. That means 20a is equal to 4. So a is equal to 4 upon 20. That means a is equal to 1 upon 5. This is the value of a. And what about p? You can say that for the third term, 190 a square is equal to p. And then a you have found 1 upon 5. So 190 times of a square, 1 upon 5 square into 1 upon 25 is equal to p. And then p is equal to 190 upon 25, or if you divide you will get 7.6. This is the value of p and a. One of the term in the binomial expansion of 1 plus ax to the power 20 is qx4, where q is constant. Find the value of q. So again, if you see that in this second in the part C, we need the term involving coefficient of 4, that means x4. So you can write the whole expansion till 4 term, or you can use a direct concept of if you need coefficient 4th term to the power 4. So the idea is we have expansion n4 a to the power n minus 4 and b4. This is the expansion of a plus b whole power n. If you need to find the term involving b to the power 4, that's how we do that. So n4 a to the power n minus 4, 4. So a is the first term of the expansion, b is the second term of the expansion. Because we need qx4, this is the second term, x is the second term. So we can apply this approach in our given expansion. So I can write that 24 1 to the power 20 minus 4, which is 16, and ax whole power 4. And this 20 C4, this 24 you can use your calculator. In your calculator you will find 20 C4, and if you do that, so you will have 4.845. 1 to the power 16 is 1. A we have found 1 upon 5, and 1 upon 5 means it is 0.2. So a to the power 4 is 0.2 to the power 4 and x to the power 4. Clearly you can compare, you have qx to the power 4 and you have this as a coefficient. So you say that q is equal to 4.845 into 0.2 whole power 4, and you simplify this, so q would be equal to 7.752. Thank you very much for this video. Have a nice time.